In our previous video, we discussed about different types of fundamental data types. Now in the upcoming video, we will discuss about data type modifiers, and also we will discuss derived data types that can be created using fundamental data type. So come, let's begin it. Now we have already studied fundamental data types in C++, different types of fundamental data types. Related to that topic is another topic, data type modifiers. Data type modifiers are nothing but are used to modify a data type. As the name suggests, they are used to modify the data type. They modify by increasing the efficiency of that data type. For example, we can increase the efficiency of int, float, char or double by using data type modifiers. There are three types of data type modifiers: signed, unsigned and long. Now we will see how they modify each of the fundamental data types. Suppose we have to modify the fundamental data type, say int. Size of int is 2 bytes. It occupies 2 bytes in the memory, and range of int is -32768 to 32767. Range means, suppose we have declared a variable int a, then a can have values ranging from -32768 to 32767. The largest value we can give to a is this, and the smallest value we can give to a is this. If we try to give more smaller value than this, suppose -62768, I write to a is equals to -62768, then int will not be able to accommodate that much of space to a. And if I write some number larger than this to a is equals to say 32768, then also a will not be able to accommodate in its memory the larger number than this. So this is the range of int. Now we have to modify this range of int using data type modifier. So we apply unsigned before int. Now unsigned int has a range 0 to 65535. What has it done is, the negative range of the int is added to the positive range, and there is no negative number now. Now if we declare unsigned int a, then a cannot take any negative number, but it can take the positive numbers up to this much value. So it has modified the capability of int. We were first writing int a, but now we will write unsigned int a to declare a variable of unsigned int type. There is another data type modifier, signed int. Signed int is perfectly same as normal int. There is no difference between two. Now we will look upon long. The int was taking values ranging from this to this, unsigned int from this to this, and signed int was same as original int. There is another data type modifier, long. Long occupies 4 bytes of memory in your PC. But note that long, being a data type modifier, cannot be used with int. We cannot write long int, although it is also correct, long int is also correct, but only long will also work. Int has a range from this to this, and long has a range from this much negative number to that much positive number. So we have only to declare a variable of long type, suppose long a. Now a can take this much negative value to that much positive value. We don't need to write long int a, we can only write long a. Similarly, as int was being used by unsigned, long can also be used with unsigned. We write unsigned long, it has a range, it will discard the negative side and add this negative memory to the positive side. So 0 to 429496 7295, it can accommodate this much larger value of a. So these are the different variations of data type modifiers that we can use to accommodate a larger number to a variable in C++ program. Int has a size 2 bytes, long has a size 4 bytes. We can also call long a data type also, as we have no need to write int with it. We can directly write long and preceding it the variable name. Now to accommodate the decimal numbers, we already have two fundamental data types, float and double. Float occupies 4 bytes of memory, double takes 8 bytes of memory. Float has 7 digits after the decimal and double has 14 digits after the decimal. By applying the data type modifier, we can increase the range of double by writing long double. Long is a data type modifier. Long double, its size goes to 10 bytes and we can accommodate 19 digits after the decimal. So this is how the decimal numbers can be stored. Larger decimal numbers can be stored in a given variable in C++. Data type modifiers can also be used with char data type. Char data type occupied 1 byte of memory and the ASCII codes of characters can be ranging from -128 to 127. But if we need to modify this char, we can write unsigned char. It will also occupy 1 byte of memory, but now the ASCII codes of those characters will range from 0 to 255. Unsigned char is the notation we use in our computer memory to store the characters in the memory. All the ASCII codes are of positive range, that is of 0 to 255. The signed char is similar as char, there is no difference. So we have discussed the data type modification of int, float, double and char. The other data type is void data type, which cannot be modified. It is already null. It is the same thing if we modify it or if we not modify it. There will be no difference in that. Now we will discuss different types of derived data types. We have studied fundamental data types and their modifiers. Now it's time for derived data types. There are 5 types of derived data types: arrays, functions, pointers, references and constants. By the term derived means if we modify the fundamental data type according to our needs, then it becomes a derived data type. Derived means we have developed them ourselves according to our need, but the major building block will be the fundamental data type only. We will modify them to make derived data types. We will discuss one by one each of what they are. Now let's discuss the first type of derived data type, that is the arrays. Arrays are a named list of finite number of similar data elements. Now by this definition I mean, listen carefully, suppose an array of integer type. I declare an array of integer type. It means I use the fundamental data type as integer and modify it to get our derived data type array. I take an integer data type and modify it to form an array. An array of integer type will be a named list of finite number of integer data elements. Suppose you have a list of numbers and you give that list a specific name, then that named list will become an array of integer type. Similarly, a named list of float numbers will become an array of float type. A named list of characters will become an array of character data type. So we can build an array with any type of fundamental data type by specifying a size of the list and a name for that list. If we specify both of these things, then we can say that we have constructed a derived data type array. Consider this example. We declare array as, this is the syntax. First we write data type, then we give a name to the array. This name to the array is the same that we give to the list. I was saying named list. This is the name of that list, array name, and size of that list. I write int salil in the brackets 4. Int is the data type, name of the list is salil and size of the list is 4. This means I have created a derived data type array whose name is salil and can accommodate 4 integer numbers. I have declared a derived data type array of name tutorial which can accommodate 10 numbers of float type. I have declared a derived data type array named mart which can accommodate 5 characters. So this is how we modify int, float and char to form a new data type array which is a derived data type. So I hope so what is meant by derived data types is now clear to you, and arrays are also clear to you. Moreover, we will be going to discuss a full new chapter of arrays later on. By this time, this is the introduction only. You can note this down in your notebooks, and please ensure that you have noted down each and every point that I have spoken. Now here is an example of an array. I have declared an array named salil, that is a list named salil of 4 integers. That is, this is the memory map in our program. There will be 4 columns. These 4 columns are for integer. Each column can hold an integer. As I have declared size of 4, so the array will be created of 4 spaces. Each space can contain an integer number as we have declared the array of integer type. You cannot substitute here float or character when you have declared integer. Only what you have declared here, similar type of numbers you will insert in the array. Here note that I have given the size 4. So in memory the count starts from 0. So 4 blocks will measure from 0, 1, 2 and 3. So this is the difference between an array and a fundamental data type. A fundamental int a, I have declared normal object or variable of type integer. Here a can hold only one value. You can give any value to a. Suppose a is equals to 4 or a is equals to 7, but at a time it will remember only one value. But in case of arrays, whatever the size you will identify here or write here, that number of elements you can identify in an array simultaneously. Here I am identifying 14, 13, 47 and 48. That is 4 elements are stored at a type in a single name. Salil is a single name here and storing 4 numbers, as we have declared the size of array as 4. Here a will store only one number, as it is not an array, it is a fundamental statement, fundamental data type. So this is the difference between a fundamental data type and a derived data type array. Also note that size of the array is calculated by this formula. Declared size, here declared size is 4 multiplied by size of the data type used. Data type used is int. Int is of 2 bytes in C++. So 4 into 2, that gives 8 bytes. Each cell will be of 2 byte. Here 2 byte, 2 byte, 2 byte and 2 byte. The sum will be 8 bytes. Each cell will carry an integer. That's why the value of each integer is 2 bytes multiplied by size. So 8 bytes is the size of this array. So you can create any customized type of array depending upon your need. Now let's discuss more about arrays. Arrays can also be multidimensional. Like this is in single dimension, arrays can also be multidimensional. Let's consider one example. So here we have designed a multidimensional array. The syntax has some change. Data type, name of the array. Now here there are 2 brackets that we have included 2 sizes. The first bracket will include the size of rows, that is number of rows, and second bracket will include number of columns. Here I have written 4 4. That means the list Salil will have 4 rows and 4 columns. Here is the example: 0th row, first row, second row, third row, 4 rows, 0th column, first column, second column, third column, 4 columns. So the data is arranged in the case of multidimensional array as in the case of matrix. So 1 is the first element of this array, 2 is the second element, 3 is the third element, and so on. 16 is the 16th element. This is how the data is stored in the form of rows and columns in multidimensional array. Now how to store the data in this format and how to store the data in single dimensional format, that we will discuss later on when we will discuss the whole chapter of arrays. By this time, note this down in your notebook as it is. The next type of derived data type is functions. Functions are a named part of a C++ program that can be called or invoked from other parts of a program when needed. Suppose you have written a big program of 1000 lines. Now in that 1000 lines, you divide that program into suppose 100 lines, and each part of 100 line is given a name, a specific name. That part of that program becomes a function. Now whenever in our program, suppose you have made a program of a calculator. Now in that program, addition operation is also there, multiplication is also there, subtraction is also there, division is also there. So there will be some number of lines that associate with each of the operation. Suppose for addition operation you have 3 lines, for subtraction you have 3 lines, division you have 4 lines, and multiplication you have 4 lines. That each part of the program of 3, 3, 4 and 4 will be given a name. Suppose addition, subtraction, multiplication and division. Then that one named part forms a function of a program. We can call or invoke that function anywhere in our program to perform the specific task that is defined by those number of lines. Suppose someone has some work from you, then they will call you by speaking your name. Similarly, in a C++ program, whenever we have some tasks from the function defined, we will call them by naming them. We will call them by their name. The function will come and perform its task and then go away. This is the use of functions in our C++ program. The very best example of a function is clear screen that we have used. Clear screen is a function that is defined already in conio.h. The clear screen function has some code of lines behind it. There are a number of lines written that perform the task of cleaning the console screen. So that lines are visible to us only in the header file. We have to explore the header file to see the lines of that code. But in actual, when we name it, we call clear screen, the clear screen function comes, perform its task and goes away. This is how functions work in a C++ program. Another example of a function is getch function. Getch function does the task of entering a character from a keyboard. Till that time it retains your output on the screen. So every function has a specific task, and that task is performed by the specific number of lines that are code behind it. So this is how functions are used in C++ program. We can also define our own functions in a C++ program also. This functions topic will be also discussed later on as a full chapter in C++ 11th class only. And for the beginners level also we will discuss it in the same playlist. Now another type of derived data type is pointers. A pointer is nothing but it is also a variable, a type of variable or object in C++. Only difference between a normal variable and a pointer variable is a normal variable will store a value for you. Suppose we declare int a and a is storing 10 in its memory. But a pointer variable will not store the values like this 10 or 10.41 or some character. The pointer variable will store the memory address of a normal variable in a C++ program. Suppose a is stored at memory location 1041 in your memory, in CPU memory. Then a pointer variable, say ptr, will store 1041. Pointer variable will store the memory address of some other variable in your C++ program. We declare pointer variables deliberately when we need them in our program. So note this down. A pointer in C++ is a special variable or object that stores the address of some other variable or object declared in the program, and this is the example. Now I will tell you how to declare a pointer in C++. Suppose we have declared a variable a of integer type and we have to store the address of a in some pointer variable. Then the syntax to declare a pointer variable is data type star pointer name and semicolon. Data type is the any fundamental data type that you can use in C++. How will we determine this data type? Suppose we have to store the address of a in our pointer variable, then we will see the data type of a. It is int, so pointer will also be declared of int type. So we declare int star ptr. Ptr is the pointer variable that will store the address of a. Then how will you store the address of a? You will write one more statement, ptr is equals to and a. This and will assign the address of a to ptr. We read this statement as address of a is assigned to ptr. So ptr in its memory will now carry 1041, that is the address of a in CPU memory. So this is how we declare a pointer variable and assign to it address of some other fundamental variable in our C++ program. This is the syntax. Suppose if I have written float a, then I will declare the pointer of float type, float star ptr. Ptr is equals to ampersand a. So two statements are necessary to assign address of some variable to a pointer variable. Not only we can write ptr, we can also give any name to this pointer variable. It's your choice only. We will discuss this pointer variable, pointer topic whenever we move to advanced C++. In beginners level you have to consider only this much, and also for CBSE 11th class also you have to consider only this much. Now we will move on to another derived data type, references. References are also derived data types in C++. Now a reference means it is an alternative name that we can give to an object or variable. Suppose I have declared a variable r of integer type and I want to give an alternative name to r. I want to call r by say another name radius. I want to give another name radius to r. So I will use references derived data type. We can say it as nickname of an object or variable. Now r and radius, both the names of that object are valid, but this does not mean that some another memory for a new name will be created. The memory will remain same. R will be also pointing to one memory and radius will also be pointing to the same memory that is pointed by R. Memory remains same. Only thing is we can call it by some another name, like you have nickname of yourself. Similarly, references are used to give nicknames of variables in C++. Now I have to declare a reference for this variable r. Then how I will write? I will copy this data type directly as it is here, and this old name or this name as it is here. In between two, I will put assignment operator. Here I will write and radius. Now the statement becomes is int and radius is equals to r. Now this radius is a nickname of r. I call it r or I call it radius, it means one and the same thing. So this is how we declare a nickname of a variable in C++. Constants are the another type of derived data types in C++. By the name constants, we mean that constants are the objects that can never change their value. Note this down, objects that can never change their value. Now understand a very minute point. In our previous videos, I always use the term object and variable interchangeably. You have noticed many times whenever I was declaring any object, suppose int a, I called it variable also, I called it object also. So now I want to clarify that why I did so. Many of the books and many of the teachers will guide you to say the term variable every time. This is not true. Remember this point, this is not true. If you don't know the difference between object and variable, you should always speak it as object. You should never speak it as variable. A object can be constant also, variable also. Means suppose I have declared int a. A can have value changing at all the time in our program. Suppose in one line I have written a is equals to 20. In other line I have written a is equals to 30. So a is changing its value. At that time it is a variable. But if a retains its value 20 at every point in the program, it will be treated as a constant. So this is the difference between a constant and a variable. And so the object is the major term that describes both. An object can be constant also, an object can be variable also. As now we are cleared with the concepts of constants and variables, we should only use the terms between both of them, either constant or variable. You should be specific with it. So I should tell you how to declare a constant in a C++ program. Let's discuss it. Let's discuss the syntax of declaring a constant. Now I have written here two statements. Int age is equals to 25, const int age is equals to 25. Note the difference between two. Here age is an object which is a variable. How can I say that it is a variable? Here age is firstly initialized a value of 25, but anywhere in the program we can change the value of age. We can call it age is equals to 40, then 25 will be replaced by 40. We can then again replace 40 by some other value. So this statement will treat the object age as variable. But if we prefix a keyword, what is a keyword? That has some special meaning. Const has a special meaning to make an object declare as a constant. Const int age is equals to 25. Here the value of age is now constant, that is 25. Anywhere in the program, if we try to modify the value of the object age, the program will generate an error as we have declared it of constant type. So this is the difference between a variable and a constant and the term object that describes both a variable and a constant. So by this time we have completed all types of derived data types. I hope you have noted each and every point in your notebook and prepared well notes. Now I hope you liked my video and your concepts are being cleared. So I request you to please hit the like button also, and to please share this video as much as possible with your friends. And also, if you want to watch the previous video, please click here. If you want to see the full playlist, please click here. Don't forget to subscribe our channel if you have not subscribed it till now. Thank you.